All right. Thank you everyone for joining today. We'll do a little bit of a slow start so as folks enter into the space. So again, yes, thank you everyone for being here today. I'm going to share my screen. All right. So yes, again, welcome everyone to the Age Well Epic Conference 2026. This session is on mobility and transportation. I'm Kelsey Harvey. I'm an assistant professor in the Department of Experiential Studies in Community and Sport at Cape Breton University, and I'll be chairing today's session. Before we begin today, I'd like to note that this is week 2 of the conference. The EPIC conference sessions taking place this week are on Zoom from 12 to 1 p.m. Eastern Time today, all until Thursday this week. We encourage you to attend all of these sessions and to check out the Age Well Epic Conference webpage to download the Age Well Epic Conference program, which includes details on each challenge area session, or if you want to watch any recordings from last week's session. I'm coming to you from Unama'ki, an ancestral and unceded territory of the Mi'kmaq Nation. This territory is covered by the treaties of peace and friendship, which did not deal with the surrender of lands and resources, but established the rules for what was to be an ongoing relationship between nations, recognizing Mi'kmaq Nation's rights. We're all treaty people, and I recognize that a lot of the work presented today took place across various areas of Turtle Island. So, to introduce our topic today, I wanted to share with you one of my favorite papers on mobility. I wasn't an author on this work, but I did work very closely during my doctoral studies with several of these authors. So, we often think of mobility in narrow sort of ways of improving physical mobility, or in the case of things like transportation, built environments. So getting from one place to another. So the paper, Meanings and Feelings of Immobility and Mobility in Later Life, Case Study Insights from a New Mobility's Perspective by Grenier and colleagues, asks us to think of mobility as more than just point A to point B, more than physical mobility, more than transportation. And really there being a spectrum from immobility to mobility in a variety of contexts. For example, one person might be immobilized by fear, right? And that's an emotional experience of immobility. That same person who is feeling immobilized by fear may be because they're experiencing upward mobility in a financial and socioeconomic sense. So, sociological examples can also include not just financial and socioeconomic mobility, but also mobilizing groups of people for social change. This conference is a great example of knowledge mobilization, how we mobilize knowledge. So there's a lot more to mobility than physical and movement related concepts. And that richness of looking at the concept of mobility from different disciplinary lenses is also what makes sessions like today's conference very rich. I'll share one example from my own work, which is currently under review and not yet published. I worked with Dr. Brenda Verkulen at McMaster University a couple years ago. I was a research assistant on one of her projects. She had developed an educational platform called the I Am Human Conversation Exchange. It consisted of education modules to teach post-secondary students about intersectional ageism. The second part was to engage in intergenerational conversations about the topic of mobility. And this particular project was in the context of driving and the advancement and development of electric vehicles. So this project, what we were curious about was how these students then learned about ageism. And then the students spoke with older drivers, and older drivers shared their perspectives on transportation, their experiences with transportation, as well as feelings around mobility and their perceptions of the future design of electric vehicles. So for this project, without getting into a lot of the details, there are many definitions of mobility. Beyond the obvious physical and mobility and transportation, Dr. Verklian informed the design of the I Am Human conversation exchange on existing models that mobilize allyship. So knowledge mobilization into an educational platform, mobilizing people to become anti-ageist, to reduce bias, and to form intergenerational solidarity, working together across generations. By engaging in the education and intergenerational conversations, knowledge was also mobilized in other ways. Students learned about ageism. They also learned relationally about older people's perspectives on electric vehicles. Older drivers we spoke to shared their experience of being mobile in many ways, and examples that really stood out that students spoke about and were engaged with were one participant talked about their favorite sport being walking soccer and how they would travel from place to place competing and playing walking soccer. Another participant shared memories of driving a motorcycle around Europe and how that wasn't something that they felt they could do any longer. So these stories were not only how participants embodied mobility, so how they talked about that experience of what it felt like and what it feels like to go through these changes, but those stories also demonstrate how older people saw their mobilities change over time. And again, these were stories that stuck out to students because they challenged some of students' preconceived notions about what it meant to age and what it meant to experience mobility in later life. So today, as we listen to the presentations, I invite you to consider the many ways we conceptualize and experience immobility, mobility, aging, and technology. Oh, so there we are. So for today's presenters, we have two research presentations, each followed by a 5-minute Q&A. And then there's a moving the dial presentation featuring a startup. So, and then we will conclude the session with a general Q&A. So I'm excited to introduce today's EPIC conference presenters. I'll go through each of them first and then a more detailed breakdown for our first talk. So we have Ben Cornish and Kathy Holden, who will present reflecting on the methodological approaches for wearable sensors, considering the person-level factors when quantifying mobility in daily life. We'll then have Felix Nindorera and Roxane Perinet-Lacroix, who will present efficacy of a video feedback-based mobile app on balance confidence in older adults using walking aids, preliminary results from a randomized controlled trial. Finally, Miraz Hack will highlight how Quantum Robotic Systems Incorporated is moving the dial by improving quality of life for Canada's older adults and caregivers. All attendees are encouraged to use the Q&A box to ask questions, leave comments on a question, and upvote questions that others have submitted. We also welcome you to use the chat. The session is being recorded and will be available for playback. Links to playback will be posted on the EPIC conference webpage and the AgeWell YouTube channel. Should you choose, you can enable closed captioning for Zoom on the Zoom toolbar. So without further ado, I'm going to stop sharing my screen so that our first presenters can get started. So our first group, presentation number 1, with Ben Cornish and Kathy Holden. Ben Cornish is a postdoctoral fellow at the McMaster Institute for Research on Aging at McMaster University. His research focuses on aging and mobility with a particular interest in using wearable sensors to measure walking in daily life. Part of his research focuses on optimal sensor setup, such as single or multi-sensor, and analytic approaches to measure mobility in daily life, with hopes to better quantify and understand how mobility relates to health outcomes. Kathy Holden is part of the McMaster Monitoring My Mobility, MAC-M3, Advisory Committee, and an active participant in the study. She's 69 years old and retired from 17 years as an office administrator for a veterinary clinic. She was a stay-at-home mom most of her adult life, as well as an office manager at a ski hill in British Columbia in the 1980s. Kathy's been part of the MAC-M3 study since the beginning and was involved in the preliminary discussions, making decisions about wearables and testing adhesives, and a presenter in many of the Zoom conferences during the COVID-19 pandemic. All right, I will turn it over to Ben.
Great, thank you. I'll share my video. Kathy couldn't make it today, so we recorded our presentation last week together. So it's going to be coming to everyone via video. Okay, thank you for the introduction. Our talk is titled Reflecting on the Methodological Approaches for Wearable Sensors, Considering the Person-Level Factors when Quantifying Mobility in Daily Life. So mobility has been considered the sixth vital sign, and there's lots of examples of mobility in daily life. But here at MACM3 and McMaster University, we're following the World Health Organization guidelines, and we define mobility using any movement in all forms, and this can be powered by the body, like walking, or using a vehicle like driving.
For me, mobility is very important as I age. Being able to do things at home and being able to get out of the house and go places, do my shopping, go exercise, do my errands. It's something that helps me maintain my quality of life. And I want to be able to maintain that level of activity as long as I possibly can.
And one problem with mobility is that it's pretty difficult to measure, especially for research. There are many different tools like questionnaires and surveys, but these are subject to biases. So MACM3 study is using wearable sensors to measure mobility in daily life.
I was part of the MACM3 study from the very beginning when we were just sitting around a table and discussing what it might look like, what sensors could be used, what people would be comfortable using, and discussing, how things would fit what people wanted to do. The sensors chosen were the tick watch for the wrist and then the actigraph for the thigh. The small black one, I forget what it's called, was an option later to overcome the bulky size of the red device. For myself and all my friends that were in the study, that small black one was way more comfortable. After having been a part of the study, there are three things I would suggest for future studies. First one would be the size of the wearable sensors, in particular the watch. For many of my female friends, that watch was just too big and bulky and it wasn't comfortable. Um, the straps were often uncomfortable. They could be hot and slidable. Just from other things, I know we use silicone straps and they're much more comfortable than the rubber ones. Um, and it would be nice to be able to customize the buttons on it. When you have your watch buttons sitting right here and you bend your wrist, for example, when you're gardening, it becomes really painful because those buttons dig into it. So if you could make it more comfortable for people to wear, if you could switch the buttons so they can be used on the other side, those were just some of the things that I thought about.
Yeah, perfect. So the MACM3 study is a prospective cohort study, and its main goal is to characterize later life trajectories in early mobility decline. The MACM3 collected 1,555 older adults that were over the age 65, and none of the participants self-reported major mobility limitations at enrollment. So everyone was fairly mobile or was very mobile at baseline. Within MACM3, we used a unified framework to characterize mobility, which measures mobility in what we think we can do, what we can do, so in clinical tests, what we can do, and then lastly, what we actually do, so using the wearable sensors to measure what people are doing in their daily life. And the focus of this presentation leverages the idea of these multiple sensors in MACM3, so one was worn on the thigh and one on the wrist, to understand the effect of wear location for calculating important measures of mobility in daily life, like step counts. So we focused on step counts because it is the most common measure of daily life mobility and has several downstream effects when calculating walking quality in daily life. And there's also no standard or guideline to measure stepping in daily life, and it's largely dominated by convenient wear locations like the wrist. So we wanted to understand the difference in step counts across wear locations when using different algorithms to determine if any mobility-related factors are associated with the differences in these approaches. From the total cohort, we had about 640 participants fit our inclusion criteria. They were 74 years in age and 70% of them were female. And each of the participants wore both the wrist and the thigh sensor for a minimum of 3 days during their collection period. We analyzed the accelerometer data for 4 different step count algorithms, but today I'm only going to report the differences between the 2 open source algorithms but we also used commercially available algorithms as well, and you can kind of see that in the table there. So the first open source method was a machine learning algorithm built specifically for the wrist, and the second was a frequency-based algorithm specifically designed for the thigh data. And then lastly, we examined the relationship between some of these personal mobility related factors that we measured using that unified framework that I mentioned earlier, and how it was related to the differences between these 2 open source methods. So this slide is quite busy, but starting on the left, our step count difference between the 2 open source methods was relatively low, coming in about negative 95.39 steps per day, and with a standard deviation of about 2,000 steps. So you can kind of see the variability is a little larger around that mean. And when we looked at the relationship with mobility-related factors, there were 4 that were significantly related. So first, the clinically measured walking speed. So when we tested people in clinic walking over 3 meters, if people walked faster or slower, that was related to differences in their step count measure. Whether someone actually reported using a mobility aid like a cane or a walker within the last year was also related to step count differences between these methods. The total derived activity duration, so we used standard approaches to measure moderate vigorous physical activity, and that was related to differences in the step counts. And then if someone had reported multiple chronic health conditions, that was also related to step count differences between these 2 methods. And the message here is that the method to calculate daily life mobility really does matter. Whether you're using wrist-worn or thigh-worn devices and the different algorithms, specific characteristics of older adult movement are related to differences in these step count outcomes.
One of the things that I enjoyed participating in this study was the feedback that we got from it. I enjoyed getting the outcomes because it's nice to receive something about what we did that can be valuable for understanding our own personal mobility and also for comparing ourselves to other people in our age group that were also participating. Although good, there's a couple things for measuring mobility that could maybe be changed or improved. One of the things is for me, like I'm not sure that step count is the only value. An example being that if I go for a walk with a friend of mine who has shorter legs, we can walk exactly the same distance in exactly the same time, but I will have 5,000 steps out of that walk and she'll have 7,000 or 8,000 steps. So is step count actually measuring accurately the value of that activity for the 2 of us in the same distance? Also in the in-person testing, I think that possibly another important measurement that was missing, we did all kinds of sit stands and walking distances and what have you. But a measurement that's important to me and many of my friends, again, that talked about in this study is standing and squatting and getting down, being able to get into your lower cupboards in your cabinets or decorating your Christmas tree at the bottom of the tree or whatever it happens to be. But just that movement is very important and that adds to your continued mobility. Couple of things like talking to other people that were in the study that they would really like to see. A lot of them mentioned they'd really like to see it waterproof. And I know that that's not easy to do, but a lot of people are active in different ways. And then I had a couple comments on the battery life of the tick watches, that they didn't feel it accurately measured for them because the battery ran out before their day ran out. Overall, I think it did a great job. It was very enjoyable to participate in it and very interesting. And I'll look forward to what happens going forward.
And then with that, we'd like to take the opportunity to thank all our funding. And personally, I want to thank all of the MacM3 team, as well as all the participants that participated in this very rich data set, provided lots of their own personal time to volunteer. Without volunteers and participants in the study, we wouldn't be where we are. So again, thank you to AgeWell and everyone else, and thanks for listening to our presentation.
Great. Thank you so much, Ben. And I know Kathy couldn't be here, so pre-recorded, but thank you to Kathy as well. There's so far there's just one question in the Q&A, but if anybody would like to add more to the Q&A, just one came in. Are you looking at other devices like Hume?
I'm not familiar with the other device that was mentioned there, but there are plans to try to expand, our use of different devices in measuring mobility. I think the tech side advances very quickly. It's hard to keep up, especially with commercial devices. So we're trying to tackle this in two different ways. One would be do an evaluation of what exists for people to buy commercially, but then also try to partner with companies that are developing new devices to not only advise and provide information to make their devices more appropriate for the aging community, but also to kind of expand the different sensors to fully encompass mobility measurement, not just from body movement itself.
Great. And this question is, how, in your opinion, does measuring mobility in older age, how can that support improvement in older individuals' social and mental well-being?
Yeah, that's actually a really good question because it gets to the point of what we're all trying to work towards, which is help people improve their daily lives and improve their own health and et cetera. I think from our perspective in MacM3, this initial stage of the study where we're really trying to capture what I've used air quotes, but what normal might be, but it really just what does our population look like in terms of how mobile they are and what key factors are related to adverse outcomes. From there, we can start generating guidelines, creating generic guidelines, but also guidelines for the individual because everyone has their own individual needs to help people improve their daily life mobility and how that relates to some of these adverse health events that do exist and happen. So I hope I addressed that.
Yeah, that's great. Another question just came in. What tool did participants like the most during the tests?
If they're referring to the clinical tests, like in lab, I think a lot of participants enjoyed some of the tests that give immediate feedback so they can kind of see how well they did. If they're referring to the devices, the device that people liked the most was the small black device that Kathy had highlighted. It's called an Activity device. It's quite small. It captures a lot. It can capture and store a lot of data, so it's not limited by battery life like some of the activity watches are. But the location of that device in itself on the thigh isn't always a preferred location. Some people in the MacM3 study did mention they did not like the thigh and prefer the wrist, but it came with its own limitations. I would highlight too that that device can be worn on the wrist itself too and give you high quality data outcomes.
Great. Well, thanks so much. Anything else that comes in, I'll save for the general Q&A at the end of the session today. So thank you, Ben. Really appreciate it. And yeah, so if there are any other further questions for Ben, we can keep those at the end. And so we'll move things to the next presentation number 2. For this, we have Roxane Perrinet-Lacroix. She's the Director of Administration and Innovation at Adaptive-E, a community organization dedicated to enhancing the well-being of individuals living with functional limitations through adapted physical activity, sports, and social programs. A trained kinesiologist, she has more than 16 years' experience working with people with disabilities and older adults with reduced mobility. She's actively involved in collaborative research projects across Canada focused on developing inclusive tools and programs to enhance participation and quality of life within communities. Joining Roxane is Felix Nindorera. He is an Age-Well EPIC AT Fellow, currently completing a postdoctoral fellowship at the Université Laval in Quebec. His current research focuses on mobility, walking aids, and emerging assistive technologies, including mobile applications and virtual reality to enhance independence, social participation, and overall quality of life among older adults and people with disabilities. A certified physiotherapist with advanced training in exercise therapy and intensive neurorehabilitation, Felix has 6 years of clinical experience and 5 years in research. His work focuses on developing and implementing accessible, inclusive, and cost-effective rehabilitation interventions for people with disabilities. All right, take it away.
Thank you. Let me share my screen. So, do you see my screen? So, yeah, thank you so much. Good morning, everyone. Thank you, Kelsey, for the lovely introduction. Yeah.
Sorry, Felix. We can see your presenter screen.
Sorry. Where is it? Right now, do you see my screen?
It's still the presenter screen, so we can see your script along the side. That looks perfect.
It is perfect. Okay, thank you. So thank you, Kelsey, for the lovely introduction. So we are going to present the preliminary result of efficacy of the novel video feedback-based mobile application, which was designed to support safe and effective use of walking aids. Wrong. Walking aids are used by 16% million of people around the world. And in Canada, it is over 1 million, and the majority of users are older adults. So something's going wrong. I don't see why. Okay. And you may notice that over the majority or over 50% adjust their walk at a wrong height. And the improper use of walking aids can lead to high attentional costs, high energy costs, and increased fall risk. And these have consequences of reduced mobility, reduced independence, and globally reduced quality of life. And the main problem is the lack of education on how to use and how to fit safely a walking aid. So Roxane, what are your feedback from the community?
As you said, Felix, we often see people that their physical condition change over time, but they still use their mobility aids the same way. They didn't adjust. So we see a lot of people leaning way forward on their walkers or uses their canes the wrong way.
Thank you. So, and this is documented in the literature that trainers are not well trained because healthcare workers in the program receive fewer than 3 hours on walking aid training. And we know that anyone can obtain a walking device with no standardized training, and this can increase the inappropriate or improper use risk. So that's why the mobile app, the I Can Walk, the Improving Canadian Walking Aid Skills, Running, and Knowledge have been developed and launched. And with this application, you can select the device you want to train. For example, here you can select the module of fitting, and you can watch a demo video. You can review the skill component. Then you take your own video. You can download it, you can upload it, and then you can self-assess your performance on how to fit it. And you can do the same with the gate pattern module. And if you want to know more about the application, you can scan the QR codes. So the aim of this presentation is to show the evaluation of the efficacy of this mobile app in improving balance confidence, mobility, and knowledge and comfort related to how to fit and how to use safely a walking aid. So I'll be presenting only preliminary result on balance confidence and knowledge. So the method we used is a two-site randomized control trial, which are going on in Calgary and here in Quebec. We plan to include 52 participants who were and who will be using a walking aid for more than 3 months, and we are working with Adaptavi. So going on, Roxanne.
Yeah, so we run I Can Walk project in Adaptavi. So we provide adapted services for over 2,000 of people annually. And we launch a living lab in Adaptavi. So we recruit participants that come in our services to test different projects. So we run I Can Walk project all under the living lab approach, and we recruit participants to participate in that project in our services.
So the procedure was that after recruitment and the course and signing, we run first evaluation. And after the first evaluation, the participants were randomly assigned to the experimental group using the I Can Work app or the control group using the same application but with a module of breathing exercise. This was an attention matched application. And after that, participants received 2 sessions of around 20 minutes with the assigned mobile application. And immediately we assessed with the same outcome and with a follow-up of 1 month. So the main outcome is the balance confidence assessed by the activity-specific balance confidence, which is a 15-item daily life activities on which participants can self-assess the perceived balance. And we documented also the knowledge and comfort on how they fit and the good gait pattern using the numerical scale from 0 to 10. So what are the results? Right now, we have 10 participants, mean age of 78. And what is interesting is with around 5 years of experience of using the walking aids. And the main important element here that 8 out of 10 of the included participants reported that they never received education on how they can fit the device and a good or a propagate pattern. About how they perceive the balance confidence during daily life activities, The result showed that there were an improvement of 70% in the ABC after using the application, that this difference is significant. About the knowledge on how they fit their working device and how they use their working device, there was also an increase after using daily application, but this still the preliminary result. We are waiting for the global results. So what were the participant feedback?
People were very enthusiastic about this project. They needed to have access to practice, learning, adjust their device. So they almost recruit themselves as participant to the project. And also for people that offers the service, there's a lot of enthusiasm, and they were very happy to learn that there is a tool that being developed um, to build capacity for community organism.
So in conclusion, we can say that, yeah, the app show promise and it can help teach how to feed, how to use safely, and it can be used by clinician to train using safely walking aids. It seems to be user-friendly and can be also be used by independent or people in long-term care, but we still need large control trial because we have high heterogeneity among walking aid users. As Ben told, there are many differences according to the condition, according to the device used, according to the level of balance, and so on. So thank you so much for listening. And if you want to know more, yes, email me and I'll be happy to discuss with you. Thank you so much.
Yes, thanks to you both. So reminder, you can put questions into the Q&A, and we do have one already. So what, according to your opinion, needs to be the role of authorities in ensuring safe and effective use of walking aids among older populations?
Yeah, this is a good question. There are no currently guidelines on how to fit and how to use safely a walking aid. And I think authorities can ensure that before purchasing a walking aid, you need to know those guidelines. Yes, there are some information about how we can prescribe a device, but there is no information about how it can be well used. So I think authorities have a big role to play and to help ensure the safe use of walking devices.
Right. There's a question, has the application been used in a home care context?
Not yet. This application, we launched pilot tests with community dwelling people, so didn't use it in long-term cares, but we plan it when we be aware about the result of this ongoing randomized control trial.
Awesome. Great. Exciting. Another question has come in. Does the app deal with walking sticks?
Yes, of course. With the application, there are many modules, for example, for walkers, for crutches, for sticks. But yeah, there is no module on how to fit the stick, but there is how to use safely the stick.
That is fantastic. Great. Um, yeah, I don't see any other Q&As coming in, so we'll move to the next. But if people have more questions, again, there'll be time at the end for questions to any of the panelists. Okay, so we're going to move things over to move the dial presenter, Meiraz Haq, with Quantum Robotic Systems Incorporated. Meiraz is a robotic mechanical engineer who holds a Master's of Science in Mechanical Engineering from Toronto Metropolitan University. Driven by a passion for robotics, automation, and transforming innovative ideas into real-world solutions, he's been working with QRS since completing his graduate studies. Through his work, he's contributed to the development of assistive technologies, gaining experience across the full product development lifecycle, from concept and prototyping to manufacturing and commercialization. With the support of Agewell and George Brown College, Meraz has been able to pursue his interest in assistive robotics while helping create technologies that promote independence, accessibility, and improve quality of life for people with mobility challenges. All right.
Sorry. Thank you for the introduction and the opportunity to present in today's conference. Let me share my screen. Hopefully you're able to see my screen.
Yes, we can see the slides now.
Okay, perfect. Gotcha. Sorry, let me just put it on slideshow mode. Slideshow. Yeah, and it's been a great opportunity to learn about all the research that's going on in mobility. And we at QRS, we essentially have taken that approach of mobility one step further, and we've been trying to make mobility at home specifically much easier for not only seniors, but anybody who has limitation to move around at home. A little background on the founding team and I guess the company itself. I'm Miraz Haq. I've been part of the whole production and making the actual robots for a lot of our clients. And Frank, he couldn't be here because of another appointment, but he's the main founder and the CEO of the company. A little background on what we actually do. So we're based in Toronto, and we make robots that essentially helps with the monotonous task at home, essentially. So whether it's carrying things up and down the stairs or moving a lot of loads from the front of the house to the back of the house, or even from the ground level to upstairs, our solutions that we have will help you mitigate some of these problems at home, essentially. So the key differentiator between us and some of the other robotics companies that you might have seen online is the form factor of some of the robots that we provide is completely different from what you might have seen online, with the robots being more like humans and in a humanoid form factor, which might look better, but in terms of functionality, like I haven't really tested a humanoid robot myself, but I could imagine there might be a lot of scenarios where maintaining the robot itself would be more of a challenge than actually doing the task. So that's why we're more focused on function and actually solving the problem. And here are some of the products that we have in offering. Our main flagship product is the center Scala unit right here, and it's essentially builds on top of what we had been developing for some time now, through the help of Agewell, George Brown College, and also various other funds all across the country, essentially. And one of the biggest challenges that we had tried to address was really stairs and stairs, whether it's individually you're going up or down, or even with the load, especially when you have to carry a load, it becomes really challenging. And with that, especially when you're alone, like that becomes almost impossible if you have heavy loads. So some of the units that we made. So our solution was to come up with a robotic base, essentially, that would fully take away the burden of having to lift, like a person physically having to lift uh, along as they're going up the stairs, to offloading it to a platform that would essentially, you would have to load at the bottom of the stairs or at the top of the stairs, and the platform itself would autonomously or semi-autonomously with a tablet, it would bring it down. And here's a short video of how it actually functions. With the video, you will have a much clearer understanding of how it actually works. So just to go back, that was actually one of our initial products that we had developed a few years ago, and since then we had actually improved upon on that design, and we had actually made it a lot better than what it was initially in the beginning. Here's another video. Oh, sorry. Actually, this is the same.
The sound of the video is not coming through. I'm not sure if you're aware.
Sound. Sorry. So the video doesn't actually have sound. I mean, it's only a music, but essentially, this video showcases some of the capabilities of Rosa, or like the base unit has. It can essentially, as you saw in the video, carry things up and down, and also traverse regular ground with up to. Well, we had tested it up to 60 pounds, and it had no issue essentially. But the latest version of the model that we have is it doesn't actually require any advanced application or even tablets. It's essentially a regular version of a hand cart, but with the benefit of having to climb stairs, essentially. And with this version, you would essentially just like you'd use appliance at home, or whether it's a drill machine or even a toaster. Uh, it This version has very simple buttons, mainly to go up and down, and drive forward, and like within the basic range that a user would have to do, you will be able to do right from the cart handle without having to log into any app or learn anything new essentially. And here's a video of the latest flagship product that we are actually in the market right now. the audio, actually, again, yeah, there's no audio per se. It's mainly background music, really, but it shows enough more capabilities of what the latest model can do. And at our facility, we had tested it up to carrying 60 pounds without any issue. And we're actually actively looking for participants to help us do trial runs, because like all the test scenarios are places that we're familiar with, so it's within a controlled environment. It's hard to make things fail, but when we have a variety of test environments, we can more confidently say the unit can work anywhere, really. And that's the latest version. And to continue, and whether it's the latest version or even the previous model, like we were able to get a patent on the basic mechanism that makes this motion happen. So with the help of AgeWell and also various George Brown projects, we're able to get the patent and actively commercialize. And here's another unit and here's the QB unit. It's essentially the base of the stair climbing robot. We figured the same autonomous features that you can use at home can also be applied at a lot of research environments. So we are actually
Sorry,
yep.
we're just about at time, so I don't know if we've got time for that video.
Oh,
So if you have
yeah.
something where you want to wrap up, we can move to the questions.
Sure. Yep. Just to give you a quick brief of like what the base model does, and we are actively actually distributing them through Robot Shop. But for this conference, we were actively looking for essentially anybody who are willing to like try some of these devices at their home to help with mobility issues, or frankly, if you're simply tired of taking things up and down, feel free to and if you're in the GTA, feel free to please give us a shout.
Great. We do
And
have one
thank you for
question
the
of
presentation.
does this work on carpeted stairs?
Yes. So the stair climbing is dependent solely on how thickness of like this like the carpet surfaces. So as long as the wheels can overcome the shagginess of the carpet, it can climb even on stairs as well.
Great. There's another question about the is there a particular reason for the robot to be low profile? Would it be could it be higher so people wouldn't have to bend down to add the load to it?
Yeah, so primarily the main reason of the form factor is mainly limited by the width and the rise and run of the step on a staircase. So we followed the standard regulation of like of a standard staircase, and based on that, we had basically made the robot to fit that criteria. But we could add additional attachments on top to make loading and unloading easier for sure. That would depend on, I guess, like the end user use case.
Great. There is another question in the Q&A, and if anybody has questions for any of our presenters today, feel free to put them in the chat. Just make sure it's clear who it's for. So in terms back to the carpeting question, how does the robot perform on other flooring types as well?
Yeah. So at the moment, we had actually tested outdoors, indoors. So in outdoors, we had tested it on cobblestones and then pavement. they're like, as long as the obstacles are not bigger than a 6-inch wheel, because the wheel sizes are 6-inch. So if a 6-inch wheel can overcome the obstacle or like the surface, then it shouldn't be a problem at all. It doesn't really matter which like how rough the surface is. It's more so of the height of the obstacle, really.
Great. Earlier, there was a question for Ben. What did you think about Kathy's thoughts, questioning step count as the best measure? Are you measuring other things as well?
Yeah, so in MACM3, we are measuring other things. So we have a lot of different types of measures that reflect physical activity, different activities people participate in. So those are all kind of I'm going to say body-powered measurements that we have. But we also rely on GPS to measure community mobility, and we have quite a few questionnaires that reflect on different modes of mobility, different types of activities, social engagement, reflections on the neighborhood, reflections on their own community, to present barriers and opportunities for people to either improve or those that hinder their actual mobility. So it is a large suite of measurements that we do have in MACM3.
Nice, thank you. This question's for Miraz. Do any of the robots also have a social function?
So at the moment, we don't have any community aspect built up to the robots, but like that's something I did, like I personally myself suggested to like Frank, like a, a community aspect in terms of like connecting the robots to like say other robots, and like letting the users share their challenges. I feel like would certainly be uh an approach we should take. But like at the moment, we're really thinking we're focused on scaling up our production line, and yeah, we're really caught up with that.
Great. I think we've got time for one or two more questions for Felix and or Roxanne. The app, there's a question about if it'll be available, and if so, when and how much will it cost?
Yeah, thank you for the question. Right now, the application can be downloaded for free, and it can be used whether by clinician, professional, or end users. And we hope that the application be available for all without money, without paying.
Wonderful. I'm not seeing other questions. So yeah, just a brief reminder. Don't forget there's other conference sessions. Tomorrow's session is 12 to 1 Eastern on healthy lifestyles and wellness. Everything is the conference schedule is available on A12's website. So yes, great session today on mobility and transportation. Love seeing some of the apps and devices and research that everybody is working on. And yeah, looking forward to hearing more in the future and best of luck to all of you. So again, thank you everybody for joining us here today, and hopefully we'll see you at some of the future sessions.